the other side. You unmute first. Kati aboogera
It's not sharing that.
It is sharing, it's a Nikulaba.
Yes, we would like to welcome everyone, and would like to say good evening to all of you as we start today's session. Today's session we are going to look at Java, oriented object programming in Java, and I hope for those who are around we will know where we stopped. We had not covered that much, so we are going to just continue from where we stopped. That is, we were looking at how we can input something from that. Yes, sorry. Yes, a good evening to everyone. I was saying welcoming you to the session. Today's session we are going to be looking at object-oriented programming, and we are starting from where we stopped. We stopped on how we can insert something from the however much, okay, we had seen, we had gone to control structures, then we had looked at one example, which example forced us to what? To introduce the concept of entering something from the keyboard. That is using the scanner class. So using the scanner class, we had brought some introduction, and we said why we did not continue so much is because we could not look at creation of objects at the same time, given the limited time we had. So right now we are going to start with the concept of creating objects from using a class, creating objects using a class. Then we can now understand the use of the scanner. So like I told you that for us to be able to enter something from the keyboard, we have to make use of the scanner class. And the scanner class is a system-defined class, meaning to use it, you have to first import it, right? And the only way to import the scanner class is importing a certain package in which it follows. Hoping that you remember the hierarchy we follow. There is a hierarchy we follow that in Java, we have the Java library, like this. Then under the Java library, we have the packages. Then under the packages, we have the classes. Then under the classes, we have the what? We have the methods. So, if we have a system defined, okay, Java has a Java library. Then if you want to use a certain class that is system defined or that is within the Java library, you need to first know that every class is found in a certain package. So if you want to use a specific class, an example now the scanner class, if you want to use the scanner class, you will have to import the package in which it is found. Which package? It's found in a package called utility package, which we call it as util package. So you have to first import the util package under the Java library, then you import the what? The scanner class. So for that reason, let me first admit some. Okay.
It's okay, you go.
Okay, you'll excuse us for that. So I was explaining the concept of importing. How do we import this class? We have to understand the hierarchy. That we start from the library, which is now the Java library. Then we import the package. Then we import the class. Then the class has packages. So the class has methods in it. So this scanner class has its own methods, of which we have to use. to do some things. So for example, if we want to import a class scanner, we have a procedure for importing any class. That procedure is that or the syntax for importing a class is this: import. Then what do we import first? What comes first is the Java library. We are importing from where? We are importing from the Java library. Java, import Java. Then what else? What comes next in the hierarchy? Package. Which class do you want to import? Scanner. And the scanner is found in which package? Util package. So you say import Java dot util, then dot. Now you specify which class you want to import, because one package can have multiple classes. One package can have many classes. But if a class has many, if a package has many classes, you have a choice to import all the classes or import that specific class you want to work with. So for this case, if you want to import the scanner class, you have a right to say .util then .scanner like that, then you terminate, because this is just a statement, then you terminate. So this statement here, what you've seen, the one I've highlighted, is the one that is going to allow us to import a class. And which class now? The scanner class. And if you feel like you don't want to import the scanner class itself, or you want to import everything under that package,
share the full screen tetulaba.
Temulaba. Okay, let me
Billy, ndebya yesterday. Nga biri kuli kungulu kwenyini.
Okay, so got to be 7. Okay, how is it there? Let me see.
Yeah, like that.
It's now clear?
Mm.
Okay, sorry for that, I had not seen. Okay, thank you. But I hope the audio is clear. Okay, so we are saying that if you feel like you don't know which class you're importing, just say .star instead of .scanner, meaning you are going to import any class under the utility package. So that is the statement. That's how we import. You first specify the library, which is now the Java library. Then from there we specify which package. Then there you can just import all these classes. So for this case, we want to access the scanner class, and then we say the moment we import a class here, like now we have imported the scanner class, you will be automatically importing the methods under that class as well. So for them, we don't have a specific way of importing them, but only that you need to know that all methods under this scanner class are instance methods. What are instance methods? Those are methods declared under a class, and therefore to access them we have to use objects. In other words, to work with them you need to use objects. You have to create an object for that specific class, then you can use them. Now the next important thing is now we need to learn how to create an object. How do we create an object for a class? And then this is the procedure. We learned about a constructor, but before we look at what a constructor is, let's first generally learn how to create an object. So the procedure for creating an object is that you have to specify the class name or name of the class for which you want to create the object for. Then you specify the object name. Then you say equals to new constructor. Class, let me type it just. You say class name. You provide the class name for which you want to create the object. Then you provide the object name. Then you say equals, and there is space where you see me putting a space. There is a space. Object name equals new then constructor. I'll be explaining to you what a constructor is. Then you open and close, then you terminate. Now the class name, now you will already be knowing the class for which you want to create a class name. Then the object name, you'll choose your own object name, but you have to respect the naming conventions that we talked about, the rules you have to follow when you are choosing an object name. That it should not match with the keyword, should not have a space, should not have a space in between like that. That one cannot happen. Then the other thing, it should not have special symbols in it. Those rules, you have to be putting them into consideration. Then equals new. What's this one? This is new. This one is a keyword. A keyword which we cannot change. A keyword which we cannot change. It is the one that allows us to create an instance for a class. And an instance for a class is what we have called the object. So because we know that the definition of an object is the instance of class, right? So the new keyword is the one that allows us, so if someone asks you to explain the importance of the new keyword, you just say this new keyword is used to create an instance of a class, or it is used to create an object for a class. Then this constructor, it's nothing special. A constructor is a method also, only that it is a special method in a way that it has the same name as the class name. The constructor always carries the name of the class for which you are trying to create the object. Then you open these brackets and close them, then you terminate. So that is the general syntax of creating an object. That is how it happens. Now, for example, now we are aiming at creating an object for our class which we want to use. Which class? That is the scanner class. The scanner class. If we want to use to create an object for the scanner class, there we need to use, okay, let's just do an example for creating an object. And we are going to use the scanner class. We are going to create an object for the scanner class. How would we do that? How would we achieve that? We said you start with the class name, and now the class name is what? Scanner. So we shall say scanner. You see that I'm starting with a capital S. For you dare start with a small s, you'll be wasting time. Because we said the rules are, when you are writing a name for a class, it should always start with a capital letter. The first name should start with a capital letter. And if it has multiple words in it, you have to make sure every first word letter of every new word is capital. So scanner space, then object name. Maybe we can choose SC. I'm choosing SC as my object name. You can choose any name. Then space equals space new. Now the constructor. We've said this constructor is nothing special. Again, you just write the same thing, scanner, but this time starting you like that. You write scanner. You write scanner. Then you open these brackets and close them, and then you terminate. You terminate like that. But there is not something you need to know, that now this one, however much you see, it has the same name as the class, but it's not a class. It's a constructor, a special method. We shall understand the methods and constructors, the difference. But even right now, I can talk about it. That so if someone had told you to differentiate between a constructor and a method, a constructor has these two features, that for it, the constructor always has the same name as the class name. Then it doesn't have a return type. What do we mean? Let me show you an example. An example here. An example is if you have a method like, okay, if you have these two things, int add, open and close here. Then you have another one that is add and close here. So someone will ask, which of these two, the first one which is highlighted and the second one which is not highlighted, which of the two is a method? They can just write for you the things and ask you, define which, they specify which one is a method, and on what will you base, or they can even tell you to give a reason for your answer or explain. So what you need to know here is the theory, that for a method it will have a return type. What do we mean a return type? We know that a method is a way of doing something, and because a method is a task, when you do a task we expect you to bring some results, call them some output. These results, after you have performed the method, these results are supposed to be of a certain type. You may be calculating and the answer or the output is an integer, or it may be a float, it may be a double, but anything, meaning the method after it has executed, because in the program, in the Java program, in any Java program, we have what we call the main method, the one that has full control over the entire program. So all these other small methods that we are going to be writing in the program will be they will just borrow ownership of the program from the main method. So after they have executed, or after they have run and they have gotten some output, after they have been solved or performed, they have to return their output. They have to return their output or their result to the main method which has control. So in the concept of returning whatever has come out of them, that is what we are calling return type. Whatever they return to the main method is what we call the return type. In other words, the return type is just data type, the kind of data that is going to be returned after the method has been executed. So for this, that means every method you have in the world or in your programming will have a data type. The one that you see I am highlighting to be blue, that one. So if the only way to differentiate between a constructor and a method is that a constructor will not have that data type which you have seen I've highlighted, but a method will always have a data type. So if you see in front of a method, I don't know if that is in front or behind, but at the beginning of a method, before the method name is written, for example, our method name is add, but before the method name is written and you are seeing some words, maybe before you did double, float, string, that one is what we refer to as a data type, or call it the return type, and that one will qualify there, and then you just know that is a method. But a constructor, it will just begin like this, add, then open and close without having anything in front of it. And then the other thing you need to know that a constructor will always have the same name as the class name in which it is written. So even meaning someone can write for your constructor and tells you to write the class in which the constructor is found. So the only logic you have to be knowing there is that the constructor will have the same name as the class name, so you will just write the class with the name, the same name as the constructor. Hope that one is clear. So this is a constructor here, then this one is a method. A method returns something to the main method, then a constructor doesn't return anything. For it, it is just used to initialize objects. Hope that one is clear. So if someone asks you the importance of a constructor, one is the best one is that the constructor is used to initialize objects. Then the other thing you can, if you are asked two answers, you can say it is also used to create objects. Hope that one is clear. Let's go back to the general syntax of creating an object. It is here. So you have created this object. So you see when you are creating an object for a class, you have this constructor. We have two types of constructors. You can have a constructor in which in the brackets, these brackets here you see here, in which there is nothing when it is blank. That one we call it a default constructor. Then the one in which we have something written in it, that one we shall call it a parameterized constructor. The word parameterized comes from the word parameter. So whatever you can have inside there is what we call a parameter. So those without parameters, we call them default constructors. Like this one doesn't have anything inside it. So it is a default constructor. A default constructor. But for a yes, anyone asking something?
Those with parameters inside are called what?
Parameterized constructors. Like this. Parameterized constructors. Like this. Those ones with the parameters. For example, for this one of scanner, we are going to see why I have talked about the parameterized constructors. We have parameterized constructors and what we've called the default constructors. The default ones, they don't have parameters in them. So, an example here we can look at is the, okay. Let's just even look at the one we have been working with. You see, when you are working with, we have what we call streams, input, we have what we call input, output streams. I think I had to first talk about them also. The input, output streams are three, and they are also very important to note these ones here. I talked about them, but I'm just going to go through them very fast. We have system.in, system.out, and then system.error. System.out, we know it. We know that it is used to print, display something, or display data on the screen. System.error, this one, it is used to display error message on the screen. Then system.in is the one that reads data from the keyboard. So this input system.in is the one we are going to pass as our parameter to our constructor which we have created for a scanner class. That one should happen every time you are creating an object for the scanner class. This is what I mean. That what we have done here when we are creating an example, our example using the scanner class is correct, but what qualifies it to be wrong is that for the scanner class, for it is special that every time you are creating an object for it, it should always have a parameterized constructor. Its constructor should have something written in it, and with something, this one, system.in. Why? That if you don't pass this input stream, you will not be getting anything from the keyboard. So this parameterized constructor, so for the scanner class, whenever you are creating an object for it, it should carry a parameterized constructor, in which inside it we put system.in, like I've written it there. That is how it is supposed to be. Every time you'll be creating an object for it, what will change is only one, this object. You can choose any object name, but the rest will remain the way they are whenever you are creating an object for the scanner class. Hope now that one is clear. Now someone will ask, why are we creating an object for the scanner class? Because we have said, under the scanner class, there are methods that are going to allow us to really, that are going to allow to help us allow the user to enter something from the keyboard. And this method is to use them, we have to use the object that we have created for the scanner class. Are we together? So, let's continue. Like this object we have created here, we need to know that under the scanner class, we have very many methods that are system defined also, you cannot change them. One is called the next, the method, it's called the next. Another one is called next.
These are methods of what?
Methods under the scanner class that we have to use in order to allow the user enter something from the keyboard. We have next int. We have next line. I'm going to explain all of them. Next line. Sorry, next int, next double. First next float like this. Next double. And you think you can, I think you can start putting on those brackets. I will request the Carol to mute. Thank you. So next double, next float, next int, then what? I hope that is all, Okay. Then next one. So looking at those that I've stated there, I'm going to show you when do we use each of them. So when you enter something from the keyboard, the computer initially sees it as just a character, because anything on the keyboard is naturally a character. Whether you have entered a 9 or a question mark or a full stop, it is a character. So the computer will continuously allow you to enter those characters, and that method that allows you to enter a character or a string from the keyboard is the next. That method you are seeing there. Next is one that is allowing you to enter something from the keyboard. But this time when you are entering, you are trying to enter a character or a string. So because we have said whatever we are entering is a character, what about when I want to enter a character and I want that character to be recognized as an integer? That's when now I modify my next to become next int. Are we together there? So when you want to enter an integer, you modify next now to become next int. And I think you can see that I'm using capital I. We have a rule that says that for a method, when you are writing a method or you are choosing a name for a method, it should begin with a small letter. And if it has many words or multiple words in it, the first letter of the the first letter of the first word should be small letter, and then any other letter for any other word you have used in the program should begin with a capital. The first letter should begin with the capital letter. That's why you see that next is small, starting with the capital small n, then int, which is another word, starts with capital I. And we are saying because these ones are system defined methods, you make any change, you are wasting time. They should always be written the way I've written them, no spacing in between them. Like you cannot say next space int, no. Understand? So then the other thing is next float. That's when you want now this time to enter a floating variable. Yes, if you want to say anything, I request that you just unmute and you say out, because I may not really refer to the messages. Since I'm sharing the screen, it might be hard for me to refer to the messages. Thank you. So we are saying when you want to enter a float, there you use next float. When you want to enter a double, that means a number with many decimal places, you'll use next double. Okay, so we don't need to, these methods don't have definitions, They, like, you just have to understand when you should use them. We are saying for a next, that one is used when you want to enter a string or a character. A string or a character. And the string, we said, is a collection of characters. So next int is used when you want to enter an integer from the keyboard, or integers from the keyboard. Then next float when you want to enter decimal place point numbers with fewer decimal place point numbers. Decimal point numbers or floating point numbers. Then for a double, that's when you want to enter numbers with very many decimal places. Numbers with very many DPs. So that's when we use those methods. So after we have these ones we have said they are system defined methods. So since they are system defined, to use them you need to use the object that you have created, which object SC. Are we together? So meaning if you want to use these methods, you have to use SC, then you attach it the method you want to use. Someone will ask, but you said for a method in front of it there should be data type. Yes, that one is true. But these methods, someone already wrote them long ago. Here we are not writing the definition for the method. That's why we don't need to specify the data type. Because someone who wrote these methods did all that work for us. For us, we just have to use the names of the methods. So you don't need to put the data type in front of the data type of the method should return, because someone already wrote them for you. That's why we call them system defined methods. They are already under the scanner class. They are already defined in the package. So all you have to do is to call them. Calling a method means you get the method, you attach the object, then you call it. You don't need to put to write a method definition. And what do we mean when we say method definition? Method definition is like when I wrote int, when all of you saw me when I wrote int add like this, then I opened and closed. So this is now the method definitions, that inside here I will try to provide whatever my method does. Maybe it is adding numbers, like it can be adding two numbers, maybe int c equals a plus b. That is on an assumption that I've already specified what a is, int a comma b. Then maybe I'm printing out system dot out dot print ln. Then here maybe I'm printing c. So what I've written here, this is the method name. Then what you see here is what we have called a method definition. So for a method, this is the method definition. So if you want this method to work, you have to call it in the main method. And how do we call it? By using the object that you will have created for the class in which the method is written. And why aren't we doing the same here? Like, why aren't we writing the data type or return type for the methods that we have talked about, the next methods, these next ones? Because this functionality, because this, we have said the method definition, what you see here, is the one that tries to tell us what exactly the method does. But all this sense was written by someone already for these methods, because they are system defined. What we would have written as the body for these specific methods, someone did that work for us already. For us, all we have to do is to call them and use them. So we don't need to put a method body. We don't need to specify the return type, because someone did all that work for us. That's why you see me just stating them out here. So to save time, let me just go in the coding. We do an example. We continue with the example we were working with. Okay, let me first complete here. Complete from here. I call, at least I use one method. For example, if I want to insert something from the string, I will just say, I'll create a variable in which I want to store that string by saying string, maybe name, and then I want someone to enter the name. I will use which method? We said for the string we use next. So I will create I will use the object, because we said that to use that method we have to access it using the object for the class in which the method is found. Which class? Scanner. And we created an object for scanner called sc. So we shall say sc dot, we dot the object with the name of the method by saying sc dot next. Then we open those brackets and then terminate. So what you see me doing here is that I'm calling the method next, and I'm saying get the object for the scanner and append it with the next method. Then you store whatever. This one, what you see, this thing here that I've outlined, is what is exactly allowing someone to enter the name from the keyboard. Not this one. Not this one. This one is used for creating the object. But what exactly allows someone, that gives room for someone to enter from the keyboard, what activates the keyboard is this, whatever, writing, this line. And then it is trying to say that whatever someone has going to enter from the keyboard, get it and store it in a variable called name. So never should I hear a programmer saying that A equals B when you write it like that. That is wrong. This one is not read as A equals B. This one. But rather it's read as B is assigned to A. B is assigned to A. Meaning you are getting the value in B and you are storing it in A. If you want to mean A equals to B, when you are just going to mean that A and B are equal, there you have to use double equal signs. And then that one is read as A equals to B. So that one was, by the way, I wanted you just to get to know that one. We shall use it in the near future to come. So have you seen how we have done this? We have at least tried to see how we can use this method. And the same thing happens for all the other methods. Okay, you see it's the same thing happening here. If you want to read an integer, say sc.nextInt, sc.nextFloat, sc.nextDouble, like that. Now, what next? The next thing is to now dive into our example which we were looking at. We had reached at control structures, and we were checking which number was the biggest number, and everything we were doing it from, we had just specified the numbers. But Mr. Dema asked, can't we allow the user to enter two numbers, then we tell the user which one is bigger of the two that he has entered? That's what pushed us to reach this concept of entering from the screen, from the keyboard. So let's just dive back to that example. So okay, let's now open our compilers, because we are going to start now coding. So the program we were working with, I'm just going to open it again. I don't know what we were calling it. I think it was fdemo. Okay, let's just create a new file, and then we call it Java. I'm going to call it struct. Yes. So hope everyone is able to see that. So that is the general syntax of a program. Of course, I'm not going to explain anything there. Of course, when you are trying to create a new program or a new file, they will always give you that. The computer will the compiler will always give you that basic structure. But you need to remember, when you'll be in the paper, you'll not have the computer with you. So you'll have to be knowing how you start the program. The program starts from public class, then you provide the name of the class that you have chosen. This time I'm choosing my class name to be struct. Now, we are going to write a program that allows the user to enter two numbers, then we tell the user which number is greatest. In other words, we are back to our control structures. That is a topic that where we had stopped. I think you have this link. I shared it in the group for those who had joined earlier, and I'm going to share it even today to the platform which we are using. Okay, I'm pasting that link for if you want to access Java, whatever the Java notes or its simplified notes, you can use that link. And then we are looking at control structures. Okay, they are here. Java control statements. And then we had chosen to start with the if else, the if control structure, the if else. This one, the if statement. We had generally understood how it works, and now we just wanted to find a way to allow the user to enter the numbers from the keyboard. So let's do that. So we are first going to create the variables in which the user is going to store the two numbers, in which we are going to store the two numbers. And I think let's work with it. This time let's work with the floating point numbers. Float num1. I'm just using random names. num1, comma, num2. Hope you know now what I'm doing. I'm just declaring the variables, the name, the memory locations in which I want to store those numbers that someone will enter. Then the next thing, you need to know that because we are going to enter from the keyboard, we are going to use a class, which class is defined in our Java library. So on top of our program is where we have to import the class from. On top, it's the very first statement that comes. In other words, every time you are working with a program that will require you to import something, the import statements will come on top first, always. So we are saying import, because we said we say import, then what? You specify the library, which is Java, then you dot util, that is the package which you want to import from, then dot, then star. Get used with using the star rather than importing the scanner itself. Then what next? We need to create the object for scanner by saying scanner object. We have chosen SC, let's maintain it just, but you can choose any object name, equals new scanner again. In other words, what should be here is what should be here. What here is what should be here. Then you open and close these brackets and then you terminate. Hope you can see that there is an underline on that line showing that there is an error, a red underline. Why? Because we said that for the scanner class, it does not carry a default constructor, but rather a parameterized constructor. Now you see when I put a cursor there, they are telling me that an error is found. Which error? They are telling me that no suitable constructor found for scanner. In other words, no arguments here. They expect you to put some arguments. So which arguments did we say? We said it should be the system.in stream. System, capital S, because that is a class on its own also. System.in with small I. And that one will never change. I think now you can see the red underline has moved away or has disappeared. Now the next thing is that before you have written the method, which we have said that the method you are going to use to allow the person to enter from the keyboard, you have to first specify a guiding statement. For example, imagine if you were entering imagine if you are entering your registration number on the student's portal, and they are not telling you anywhere that enter the student's number or registration number. What exactly will you be entering? Meaning, if as you are entering your registration number, someone is trying to tell you that maybe enter username as a guiding statement. A guiding statement is very important, that you try at least to know what you are doing. You see, student number or registration number, then the password. That is just a guiding statement. Meaning it's the guiding statement that comes first, then the method that is going to allow you to enter something from the keyboard, right? So all programmers are advised to do that. You enter a certain guiding statement. So what are we going to do also? We are also going to print some guiding statement before we provide the method to allow the person to enter from the keyboard. So we shall say system. We know what it allows us to print. Of course, the system dot out, then dot print ln, then you open and close, then you terminate. Then inside here, so that is how the print statement looks like. Then inside here, we provide room for entering for the state. Here inside here we provide our statements. So the statements are, and because we want to print a sentence is a collection of characters. That means it is a string, and so when we want to print it, it should be written in double quotes, and saying enter first number. Enter first number. Then from there, you have now prompted the user to enter first number. Then this statement you have written here, this line 8, is not necessarily allowing the person to enter the first number. If I run the program at this stage, it runs. And you are seeing it is telling me to enter the first number. But when I try to type, it just closes the program. It doesn't allow me to type. Why? Because in real sense you have just printed a statement telling someone to enter the number, but you have not provided a method for entering the number. So this is like on your phone, it's telling you to enter a password, but you're trying to type the password, the keyboard does not come. So you have to provide that room for the keyboard to appear by saying S is okay. We said you get the object that you have created, which is sc dot, because we want to enter what? The first number, so it's a float. We chose that it is a float. So that method we are going to use is going to be next float, because we chose that our variables are going to store a float. Then open and close, and then you terminate. You see what we have done is right, but whatever we are allowing the person to enter, we are not storing it anywhere. So we have to store it maybe in the variable in which we really want to store it. He's entering the first number. Maybe that one we are storing it in num1. So we shall just come in front here and we say num1 equals like that. You see? In other words, we are telling the person, we are now providing a method for entering from for getting whatever someone has entered, and then we are storing whatever the method has gotten from the keyboard into our first memory location num1, right? And then we are doing the same thing even for num2. We are doing the same thing for num2. So I'm just going to copy and paste, and I just modify it, save time, like that. Control V. Then I'll just say here enter second number, and now I'll just come here. I store. The method won't change. The number of times you write the method is the number of times it will allow the person to enter from the keyboard. All you have to change is maybe where you are storing whatever the person keeps on entering. So here we are changing to num2. Meaning, if we run the program will first ask the person to enter the first number. We enters, they store it in num1. Again, it will ask enter the second number. Again, it enters, they store it in num2. Now let's run and we see at this level of progress. And we run again, you see they are telling us enter the first number. When I enter maybe 6 and I press enter, they are telling me again enter second number. I enter maybe 5. Again, it closes the program, because that's so far what we have written our program to do. It's not displaying any other thing. We have not written any other print statement in that program. So we close a little bit and then we continue with our program. Our program is not yet complete, but I'm trying to run the program at every progress so that you can know what we are exactly doing. So, hope we are together before you continue to the next thing. Are we together, Wanangi? Onliners, are we together?
Yes, but can we do it together as well? Since you've been doing it alone.
Carol, be loud. I'm not hearing you.
That?
Can we try it on our phones?
Yes, you can try it on your phones. By the way, I can even share the code. I just paste the code in our platform. You continue from where we have stopped. You just copy and paste in your compiler. Then we continue on the same level of progress. As you are saving your file, save the file. Those who are going to copy and paste, you have to make sure your file name is the same as the class name in which the main method is written. The main method is on the method you see on line 4. This one. It is written in a class called struct. That means I expect your file name also to be like that, to be struct. So, hoping we are together, I'm going to keep coding as you also keep coding as we progress. Okay, so here now we have entered our two values. We have created our variables, initialized them by allowing the person to enter from the keyboard. In other words, there are two ways of initializing, where you just say int a equals 5, and then where you say just int a, you terminate, then you allow someone to enter from the keyboard. You can initialize by manually by initializing directly in our program, or by allowing the user to enter from the keyboard. So we have now used the technique of entering from the keyboard, and now we can now carry out operations on our variables. Which operations? You cannot carry out operations on empty variables. That's why never should you write the variables which are not initialized and then you start adding them or subtracting them. First initialize them, then you start subtracting or adding them or dividing them or checking anything on them. So that's why you see that even when I wanted, right now I want to check which number is greater, but I couldn't write that code for checking whether it is greater or 97, because I would have been checking things which are empty, just empty locations, which is not right. That's why you see me, I'm going to be writing on line 13 and below, after I have now done all the declarations and initializations. So down here, I'm going to write my code that is going to check which number is greater. And we were using the if statement. And we said for the if statement, you write if, this is the general syntax. You write if, then you open those brackets. Then after, you open the body. Whenever I talk about the body, I mean the opening and closing curly braces. Why is it showing the red underline? Because in those brackets which you have seen me opening, I have to provide the condition for checking which one is greater. So if you have not provided a condition, it will bring errors. That's why you see the error. When I put there the cursor, they are telling me the error is that no illegal start of expression. Inside here, they expect you to put some expression, which is a condition. So condition is, we want to check which number is greater. So we shall say num1 num1 being greater than num2. I think you can see that now the red underline disappears. So this is the condition we have provided, that if num1 is greater than num2, in other words, if the first number is greater than the second number, what should we say? Then what we should do is all written in this body, in the body of the if clause. So in the body of the if condition is where we provide our statements or whatever we want to do. They may not necessarily be print statements, but they can even be calculations. Maybe someone can say, if the condition is true, give a discount, like you saw in the other example, in the other coursework that we were doing with the lecturer assignments. So let's provide the print statement. So if that condition is true, that means if num1 is greater than num2, or if first number is greater than second number, we shall display system.out.println then you open and close, terminate. Inside here we shall print maybe a statement telling the user that the first number is bigger. Hope that one is clear. That if this condition is true, we shall say the first number is bigger. So let's run this program and we see what it really does. 6. They are telling me to enter the first number, I'm entering 6. Second number, I'm entering 4. You see, it tells me that the first number is bigger. Hope you can see there. They're telling me that the first number is bigger. Meaning the first number entered 6 and the second number entered 4, and they're telling me the first number is bigger. These other things that you see here, the last two statements, process, return, then place any key to continue. These ones, ignore them. They're just system words. They are not part of our program. Just always ignore them. Our concept is that this is our output. Then here we are trying to import So meaning this is not part of our output. This one is when we are trying to enter things. Then the output is this one. The first number is bigger. Let's run the program again. Okay, let me first explain what you have seen. When we ran the program, it allowed the person to enter the two numbers using these two methods. Then from there, it came and checked the first number. Is the first number greater than the second number? And the condition was true. That we entered the 4, 6, and the 4. And we checked that 6 is really greater than the 4. So this statement had to be executed. This one is only executed or is only looked at only if this condition that you have written here is true. If it is not true, all this becomes nonsense. They just skip it. They don't look at it. Let me try to show you. This time let's change the values. This time we want to enter the first number as 2. And then we are entering our second number as 8. Then we press enter. You see nothing is displayed. It doesn't bring our statement which says that the first number is bigger. Because real sense it's not bigger. 2 is not bigger than 8. So that means that this statement has been ignored because the condition was not true. Now you have understood how if works like. Now what if you wanted to tell the user that if the number is not if the first number is not true, which is not bigger, which one is bigger? You want to show you the other part that means the second number is bigger. That means if you have not come to school, okay, if you are not tall, then the other part is that you are short. But we don't want to reach an extent where we are only displaying the part when which one is bigger. When the condition is true, we want to even to display something when the condition is not true. Like we want to have a case where even if the condition is not true, at least we want to do something. Then so what I'm trying to mean is that what about when I'm in a situation where they are telling me that if there's no condition is not true, again it do something? Because we have seen the first one we have seen was considering a case where if the condition is not true, nothing should be done. But what about when you want to see if the condition is true, something has to be done. If it's not true, again something has to be done. For example, if the students came to class, give them marks. If they did not come, deduct. In other words, if they came to class, give them marks. If they did not come, do nothing. That's what we have just seen. What we have just seen is when the students did not came to class and we gave them marks. When they didn't come, we did nothing also. But we want a situation where if they come to class, we give them marks. If they don't come, again, we deduct marks. But this time we are looking at it in a side where we want to display the number which is bigger. If it's not bigger, then we have to say maybe the second number is bigger. How do we do that? That's when we use the if-else structure. The if-else structure. That's when we use the if-else statement. This one, number 2. We have finished number 1, so we are going to number 2. So an if-else statement or an if statement can be followed with an else statement, which executes when the Boolean expression is false. The if statement which we have seen, this one, can also be followed by the else statement, which executes when the Boolean expression is false. That means, why am I displaying to you this slide? This is whatever here. Someone can just tell you, explain all the decision-making structures briefly with an example, and they give you 3 marks. Just write these statements, simple brief statements. Then you give a simple code statement, and then you get all the 3 marks. And that's why I gave you this link, and it was very important. Statement and the description. So for that reason, we are saying now we are moving to the if-else statement. Let's just go to our code. We want to modify this code of ours to be allowing us to do. Okay, we have said that for the if which we have just seen, we can follow it by an else block, which else block is going to allow us enter from, so what? To check, to display the other part, that if yes, the first number is not true, then what? That's when we use the else statement. The else statement comes also outside the if block. Never should you write the else inside here. Like you cannot write the else inside these brackets, these ones, but rather outside here. Just come and say else outside here. In other words, the else tries to show us what should be done if the condition is not true. If the condition is not true, what should be done? That's everything, you write it in here under the else block. So it's under the else block here on line 18 and any other line that can maybe be there, where you write what should be done. In the if, this one, the if block, we write whatever is supposed to be done if the condition is true. Then here in the else part, we write whatever should be done if the condition is false. So when the condition is false, that means if the first number is not bigger than the second number, there we shall maybe display something saying the second number is bigger. You understand? The second number is bigger. I'm just using simple examples, but the applicability, you saw it already in the coursework that in the assignment, or the assignment that we saw yesterday. So the second number is bigger. I think you can see now that code. That code is telling us that this one will only execute if the first number is bigger. This one will only execute if this condition is wrong. That means if the condition is not true. Let's run the program again. Now we are running the program. And that is our output. Okay, our structure is telling us to enter the first number. Let's enter 8. Second number we enter maybe 7. They are telling us the first number is bigger. Why aren't they also telling us that the second number is bigger? Because we have two print statements. It is because only this condition was true. And the moment this condition is true, they will only execute whatever is in the block of this condition, and the rest will be useless. The else will not be considered, will be ignored. Then let's run and we change our values. When we run and now this time enter 7 as the first number, and then 99 as our second number, so they are telling us that the second number is bigger. And then that means they have now ignored the first number is bigger statement, because this condition is now false. So that means they are going to skip whatever is here and now will come and print what is in the else part. So the else part, doesn't even need to check the condition. You don't need to specify its condition. For it will automatically be executed as long as the condition in the if is not true. Hope we are together there. Friends, are we together before we move to the next structure? We are moving to the nested if. But I want to first know if we are at par there. Are we at par? When the people are sleeping, what?
No, we are moving well. Don't worry.
Okay.
Don't worry. When guys are quiet, that means things are entering well.
Okay. Okay. We are now moving to the next structure. That is the nested if. Nested if. Now, nested if comes from the word nest. The nest. Who knows the nest? Nest, I think it is this bird's nest. It is sonko in Uganda. But I can show you the nest, how the nest looks like. The nest. And when you look at the nest, I think you can see the nest is here. We have a nest, and under the nest we have some eggs. Are you seeing the nest? So the nest, in the nest we have, inside the nest we have something. Yeah? This one. Inside the nest we have something. So meaning something being inside the nest. Okay, to nest something is to get something and you put it into something. That's what we call nesting. Get something and put it into something. So when we say nested if, we are trying to mean that get if and you write it inside the if, you write another if. Let's understand that. If we have an if like this one, if maybe if A, inside here maybe we have a condition like if A is less than B, then we open and close, and then we don't only want to consider, like if you are in a situation where you want to say A is greater than B, sorry, is less than B, or A is equal to B, and you want all those two conditions to be true, you'll have to first say the major condition that, okay, you will provide the first condition outside, then inside you write another if that says if now A is equal to B, then you open and close. Here, when you look at this, what I've written here, I don't know if it is clearly visible, but outside we have this if, the bigger if, this one. And in it, again, we are writing another if inside it. So this, the whole of this is what we call the nested if. An if within another if. An if within another bigger if. That's the nested if. When do we use it? I have said we use it when you are in a situation where you want to consider two conditions, and these two conditions should be true for something to be done. For example, we usually use it for ranges, where you have maybe A is less than or equal to B, or A is less than B, and also A should not be greater than B. Oh, sorry, it should also be equal to, sorry, when you are in a situation where A is greater than B, and maybe should not exceed the C. They make it clear. Maybe you have another variable called the C. You are in a situation where A is less than B, and then A should be equal to C. And they are telling you for those two conditions have to first be true for something to happen. Let's get an example that is clear. So if you have an example like they are telling you that a student is awarded excellent if he has gotten marks, a CGPA that is greater than 3.5, and at the same time this student has never been with a retake. Yes, the CGPA is greater than 3.5, but again the other condition that this person has to first fulfill is that he has never gotten a retake. There you can have the outside if that is going to consider a situation where he has gotten 3.5. Again, you have another if inside where this person again should not have taken a retake. Then maybe you award the excellent. That's just a simple example that we can look at. But let me see which example these people use, then I can explain with that to save time. The nested if. So you think you can see the structure here. So here is an example of a nested if. Let me just copy it. You can even edit and run from here. Like, if what is so good about this resource that I gave you this link, that their code is already there as examples, and these codes you can just edit. You can go on to edit them, like you modify them, and again you run it from there. You don't need a special compiler. When you have that website, you can just edit. You can go on to edit, modify it, and then you run. So this is the example that we are looking at. I don't know if it is clear enough. That is the example. The example says that in this example we are showing use of the nested if within an if statement. An if within an if statement. We've initialized the two variables, that is x and y. I think you can see them here. We have x and y initialized. The x is initialized the 30, and then y is initialized the 10. And then they are telling you we have initialized two variables x and y to 30 and 20 respectively. Then we are checking the values of x with 30 using if statement, as if statement is true in its body, we are again checking if the value of y, okay, we are checking the value of y using a nested if. I'm going to explain that one. Okay, what they are trying to do here is that they are telling you that they are writing, let me copy it and paste it in the other bigger compiler for better viewing. So it is here. I'm just going to change this file name to remove that error. Extract. So, hope it is now clear. So they are telling us that you have to check the one that you see out, this one, from line 7 to line okay, hope you can see down the brackets that are active. The brackets that are active, that's line 10 and line 15. Line 10 to line 15 shows us the body of the external or outer if. And that one is checking if x, the value in x is equal to 30. I think you remember when I explained when do we use double equal signs, when you are trying to mean that x is equal to 30. Let me first emphasize on it a little bit. Saying x 30 and saying x, those are two different things. The first one is telling you that store 30 in x, or assign 30 to x. Then the second one is trying to tell you that is the value the x is equal to 30. In other words, it's telling you that the value in x is equaling to 30. But this one is telling you that store 30 in x. Hope that one is clear. This one says x is equal to 30. This one says assign 30 to x. So let's go back. What you see in here, the first, that is the line 9, they are checking if x is equaling to 30. Then inside they write another if on line 11, checking if y is equal to 10. Then they are displaying to you that system.out.println x equals to 30 and y equals to 10. So that when you run this program, it will tell you that really x is equaling to 30 and y is equaling to 10. In other words, if I come and modify, instead of where we had 30 and I put there maybe 90, let me run the program again. When I run the program again, you see what happens? Nothing is displayed. Meaning, the condition is not true. And for this one to be even looked, okay, what the major condition is the outer loop. Like the king here is the outer if. The moment the outer if is, the condition in the outer if is not true, the inner if becomes useless. Everything in the inner, everything inside that big if will be ignored. Meaning even this inner if will not be looked at. Are we together? That's why the moment I changed the 90, which was responsible for x and for checking if x is equals to 30, everything became useless. Hope we are clear there. Now, what if I make it 30 and I make that true? And then maybe I have some print other statements out here. Okay, what if I make it to become, okay, what if I change this one to 5, and then maybe I have some other print statements here. Let me show you. I want you to first understand these ifs very well, because they are the ones that they use to trick you when they are examining. Isn't good demonstration. Maybe we are going to display good demonstration. I'm going to explain to you why I have written this one here. I want to bring out something. good demonstration. So when I run this code, let me show you. Let me make the first the outer if to be invalid. Like I want to make the condition in the bigger if or the outer if invalid by putting the 90 here. Meaning when they come to check here, x does not equal to 30. So they will ignore whatever is inside this bigger if. Let me run the code again. When I run the code, you see that nothing is displayed. Nothing is displayed. Why? Because of course this condition will always be checked first. The moment it is wrong, it is invalid, or it brings a false, whatever is inside this bigger if will be ignored or will be skipped. Will be skipped. Will not be displayed. Will not be executed. In other words, whatever you see there will be skipped. But if there are any other statements that I wrote outside this if, Ctrl X, if I had written anything outside that if like this, are you seeing that the opening bracket for this if starts from line 10 and ends on line 16? Yes? And ends on line 11. Let me just, 15 like that. This bracket for the condition if ends on line 15, but beyond line 15 I'm writing something. Meaning, if I run the program, you can see it is being good demonstration. Why? Yet the condition is not true. The condition is yes, it's not true, because this is x is now 90, whatever is in x is 90, but when they check is x equaling to 30, the condition is not true. That means we expect nothing to be displayed, but we are seeing good demonstration being displayed. Why? Because when we look at this statement that is displaying good demonstration, it is outside the condition where we are checking the if. The body for if, the outer if, the one that is responsible for checking the condition, it stops on line 15, but our print statement is on line 16, it's outside. Even if I bring it on the same line 15, but it is outside the bracket, still it will be like it is outside, it's not inside. Again, when we run, still it will be for it will be displayed, because for it is executed not considering any condition. Hope that one is clear. Then the other thing that again I want to emphasize here is that what about if I have this one I've explained, when you have the statements inside, however this one is outside the smaller, the inner if, but it is still part of the bigger, the outer if. So meaning it will now be ignored if the condition is not true. But what about when this condition is true? We know that when this condition is true, everything will be executed and everything will be displayed. We shall see good demonstration. Let me see. X equals to 30 equals to 30. 10. Okay, I had made some wrong changes. I want all the conditions to be true, and you see what happens. All the conditions are now true. X equals to 30 and y equals to 10. When I run the program, we see that output is, let me create some new line here. Print ln. We see that they are telling us x equals 30 and y equals to 10. Good demonstration, meaning everything is displayed, because all the conditions are true. This condition is true, which is the outer condition, and which is responsible for whatever is inside here to be executed. And nevertheless, even this condition is true, inner condition, which is responsible for this one to be displayed, but it is not responsible for this one. Let me show you what I mean. That if I make this inner condition to be false by changing it 10 to 15, what will happen? What do you expect to be our output? You may feel like that condition is not one of the conditions will not be true, so everything will not be printed. No. Why? When we look at this condition, we said the outer condition will be checked first. Is it true? Yes, it is true. Meaning it will now come inside the body of the outer if. The body of the outer if goes on to first check, is this condition true? No, it's not true. Meaning whatever is in the body of the inner if will be ignored. But we see that this statement is outside of that body. Meaning what is responsible for it is this one, which was the initial condition for it will be displayed. So when we run the program, we see good demonstration being printed, but we don't see x equals 30 and y equals to 10 being displayed. Why? Because the condition for this, which is being 10, is not true. But for condition for good demonstration, which is the outer condition, is true. That's why you see the good demonstration being displayed. Hope that one is clear. You have understood how exactly these if conditions work. The nested if works that way. It is used when you want to have two conditions that you want to evaluate to do something. So let me share that code as well to you on the platform. You can go on and use it for revision, or you can even refer to our website, which we have already. So we can continue to the next structure. I hope people we are together. Before I go to the next structure, I hope we are together. The next structure is called the switch. This one is very, very important, and I would like everyone to be attentive as much as you can. This number is there in the exam. If you reach the exam and you don't find it there, you come, I pay you 100,000. That number is there by guarantee. The switch is there. Even in C++, I told people the switch is there. It came and people were just looking at it as stars, but it carries 12 marks to 6. It will never be below 6 marks. So 6 marks and above. Whether simple or complicated, it should be 6 marks and above. It can even be 8. So let's look at it briefly.
Else.
Yes.
Oh, it's only. Is it only if that is nested? There is no else that is nested.
Oh, wait. Thank you so much, Mr. Dema. You see, okay, there is something that I wanted to look to also talk about the else if ladder. You have reminded me. These people ignored it or skipped it, but we are going to look at it as well. Let me first introduce that concept too. That we have what we call the else if ladder. What you have asked, that is the else nested. The else cannot work alone. The else works together with the if. In other words, it is like a follower for if. That if this is not true, else comes in. So for it can never be nested because it cannot work alone. It is a follower for if. Maybe the one that we had not looked at is called the if else. May I call it the if else if ladder? That one. Some people call it the if else if or the else if ladder. The else if works like this. That if you have like 4 conditions, if you have like 4 conditions, you want to check, there you need to use the else if. For example, if we have a condition like A being greater than B, you have a situation where you want to check A being less than B. You have a situation where you want to check A being equals to B. Again, you have a condition maybe when you want to say they are not related. A is not related to B. In fact, what this one I'm going to explain is the one that represents or that resembles the switch. Also, this one, I will pay 100,000 to whoever reaches the paper and it's not there. This is also there by guarantee, and it will also carry 6 marks. Those are 2 numbers I've given you. You are going to be finding them in the paper and you just enjoy. So the areas that tell you convert the if to the switch to if, or they will tell you convert the switch to the if like that. So they'll tell you convert the if to the write. They'll tell you write an equivalent switch for the if statements below. Or they'll tell you write an equivalent if else statements for the switch below. So for that case, we are going to first understand the if else if ladder, then we can now move to the switch, and we shall see how they are related, how they can tell you to convert them. Let's look at an example where we are implementing these four cases. A case where A is greater than B, less than B, equal to B, and not related. Let's see it in the coding. Let's code one example here. I think we can use the other program where we are allowing the person to enter from the keyboard, and we just go to modify. I think we no longer have it. It's okay. Let's work with this one. Let's just work with this one. Extract. Let's work with this one. Then we are saying, should we allow the person to enter from the keyboard? Maybe no, it's not necessary right now. We are just understanding some brief things. I'm just going to remove this nested if like that. Yes. Now we want the first. We are checking, is x greater than y or y greater than x. The first, we have four conditions, which are these ones. The four conditions are these ones. Maybe let's even change our variables to be a and b. So we want to check. So we shall use the if else if ladder. Like this one is used when you want to check multiple conditions. If A is greater than B, if that one is not true, else if. May I call it a ladder that because it keeps on repeating until you reach your last case or your last condition. So let's start with the first one, which it is written like this. Like this is the general syntax. Let me first show you the general syntax for writing the if else if ladder. You write it like this. You say if, then you open and close. Then you write if that condition, if inside here you provide your condition 1, your first condition 1. Then if the condition 1 is not true, maybe you want to check another condition. There you say else if. Not else. The other one was called if else. But this one is called else if. Else if. Then you provide the second condition. Condition 2. Open and close. If again that condition is not true, you want to check another condition. Again, you keep on saying else if. Then you say condition 3. Again, if that condition is not true, open and close. Again, if that condition is not true, you provide another condition again by saying else if, like that. That's why I call it a ladder, that it keeps on going down based on the number of conditions you want to check. Else if. Then you say condition 4. Like if you have many conditions you want to consider, then again you open and close. Now when you have reached your last condition, for example, if you have 4 conditions and you feel like you have written the first 3 conditions, now the last condition you just use the else part. Always the closing block or state will be else. For it you don't provide the condition, because automatically the last condition will be true. Like what am I trying to mean? That for it we don't need to provide the condition. If you have 4 conditions and the first 3 are not true, that means by default the last one will be true. Hope we are together there. So this is the general syntax for the if else if block. That you provide the number of ifs based on the number of conditions. So for that means this person had many conditions. This person had like 5 conditions. The first one, second, third, fourth. Then these ones, if they are not true, the last condition, which is the 5th condition, will be the else condition. Let's implement that one in a program. Let's implement that one in the program. So we are writing, we are going to check our conditions. They're already here. The conditions we want to check. These ones. We have these four conditions that we want to check. A being greater than, B less than, equal to. Let's check the first one. We are going to start with A being less than. So we shall say if, open and close. Then we open our body for the first if. Inside here we provide our first expression which says A greater than B. Then here we shall write whatever we want to be done. Maybe we want to display the user that A is greater than B. So we shall say system dot out dot print ln. Then inside here we shall say, I'm putting them in double quotes because they are just strings. We shall say A is greater than B. Hope that one is clear. Then what if that condition is not true? We want to consider another condition. There we say else if. The other one which we saw, which was if, then the else, that one was used when we always use when you have only two conditions. But what if you have multiple conditions, very many of them? Here we use else if, but always the first if will just, the first condition will be if. Then those ones in the middle between the if and the last else will be else if, else if, else if, else if. This is what I'm trying to say, which we have seen here. That the first condition will be in the if, the first if. We have the first if, then at the end we have the else. Then those ones in the middle we have called them else if, else if, else if. So that's what we are doing here. So our second condition is going to be else space if. There is a space. Then you open these brackets and you provide the condition. Then but you open the body for this if also. And inside here maybe the condition is A being less than B. Then what should we print? Maybe we should print that A is less than B. I've used the wrong symbol, sorry. It's less than B like that. Then here we shall say maybe A is less than B. Less than B. Then if that condition is not true, you have maybe another condition you want to consider. That is our third condition. We had before, remember, we had greater, less, equal to, and then not related. So our third condition is going to be equal to. There we shall say else if again, until all the conditions are exhausted. Else if, open and close, open the body for that one, sorry. Open the body. Open the body, then in the body we provide, in the condition we are saying A is equaling to B. I think you can see what I have written when I wanted to refer to mean that A is equaling to B. I use double equal signs. Not with the other single equal signs. They don't mean what we are trying to do. When you want to provide it as a condition A equaling to B, you use double equal signs. I'm emphasizing that because I don't want you to make that blunder in the paper. So inside here maybe you want to say A is equal to B. Is equal to B. Then the last condition we have said, when you are writing your last condition, again you don't have to say else if. There you just say else. Else, that's our last condition. So you don't even need to provide it a condition. Just do whatever you want to do. Maybe we are saying A is not related to B. A is not related to B. Yes, there is no relationship between A and B. So when we run our program, however, you see it has very many conditions. So this is what we call the if, else, if ladder. And you have very many ifs, if, else, if in the middle here. Then at the beginning you have if, at the extreme end you have else. I don't know if it is clear. All I need to mark in, to zoom in, is to zoom out. To zoom in, is it zooming in? Those people on the platform, you can tell me, is everything visible? Otherwise, again, I'm going to copy this code and I toss it to you in the platform. And that one is used when you are looking at the if else if ladder. Very, very important. Very, very important. Someone can give it to you like that, then tells you to check to convert it to a switch. Convert to a switch, or you can give you a switch and they tell you to convert it to that one. So right now, that is how the if else if ladder works. When let's run the program and see our output. It is telling us that A is greater than B, because in real sense when we check what is in A we have 30. We have 30. Then in B we have 10. So that means they have only found out that the first condition is true. All the other conditions will be useless. They will skip them. They won't even look at them. In other words, the if else if ladder checks for one condition that is true and the rest are ignored. Are we together there? So if I come and change this 10 and I make it 90 and I run the program again, we see that A is less than B. Which one has been executed? Which else if has been executed? This one. Meaning this condition is now which is true. A is less than 10. Because we have 90 and 30. Hope we are clear there. Then the rest have been ignored. Only this one has been passed the test. If I put 30 here, let me put 30 and run again. You see that they are telling us that A is equal to B. By checking which condition has passed, condition 15. Then what else? If A was maybe a string and B is just an integer, there is no relationship. So maybe there we would have printed they are not related. And I don't want to show you that case, but as long as you have gotten the concept what I'm trying to explain. Hope we are clear there. Maybe one thing that I can emphasize is that what if I wanted not to see A is greater than B, and maybe I wanted my output to look like this. I wanted my output to look like this. I want to see if it is A, if in A we have 30, I want to see 30 is greater than greater than 70. If I want my output to look like this, I don't want to see A is greater than B. I want to see what exactly is in A and what exactly was in B. Not seeing the variables. There you will have to modify your print statement. I want us just briefly look at that concept, then we move to the last structure. So if we want to modify our print structure to match our output, because someone can be strict and I want the output to be like this. That's like you see in some of the assignment that she gave us. That one, instead of saying printing A as a string, you now print it as a variable. By removing it out inside from this, you remove it from the string like that, and you print it, you just put it outside the string. So if I take the variables outside, because our A is a variable and B is also a variable. You see that it brings errors there and then. Why? It's because we are printing two different things on the same line. So to merge them together, or to bring them together, there you will need something that is going to be able to merge them, which we call the concatenation operator. To concatenate means to merge things together. Yeah? If you want to say you have Kawe and you have EES or ES, and then you want to merge those words to bring out Kawes like this, you need to use a concatenator that is going to be like it is adding them. That is the plus sign, right? To bring up Kawes. So the same thing you come and do here. If you want to merge these two strings, the strings and the variables, in between you will have to put a plus here and then a plus here as well. Hope you can see now the red sign symbol disappears. And you'll always do the same for even the same thing here you'll do here. The same thing you'll do for each statement. Modification, same modification. Same modification. Plus B. Same modification. Sorry. Same modification. I'm just modifying it to bring the output the way we wanted it, but the program still does the same thing. A plus B. Let's run the program again and we see what changes have we made. You see 30 is equal to 30. Hope it is clear now. That instead of saying A is equal to B, now we are saying the real values in A and the real values in B. So let's change a little bit now. We remove the 30 and put 60 in one of the values of 50. Hope we can see 30 is less than 50. We are not even knowing whether we had A or B, but we are now seeing the real values. That's how the modification. That's the modification I wanted us to look at. So because the time we are out of time, we are left with fewer minutes, few minutes, only I think only 10 minutes. I would like people to use those 10 minutes to ask you questions. Then next time we come, we shall move to the switch, and then we move to the loops. Then we call it, today we are calling it a day from there. We are calling our program off. Control C. Let me give you this code also, which has been modified. You also go for, and you may be needing to look into it. So people can go and ask you questions, and then we close our session. Ask you questions on what we have covered. If there is anything I want me to emphasize, or any question you want to ask, even if it is off the Java, as long as it doesn't hit any other course unit. As long as it may even be related to our sessions, how they work, you have any improvements you want to suggest, you can go and ask. No questions? Or additions? Or subtractions?
I want to ask where 1010 is.
Good evening, the gentleman is.
Where is 1010?
It's all here.
I'm around.
Okay.
Though I'm in the background today trying to regulate the network and everything.
Yeah, it's the moderator.
Oh, you in the technical area now. Thanks for the work.
Thank you. Yes, Mr. Tewswek, you can unmute and talk.
Guys, I'd missed a lot. This session is good. It is my first session, but at least I'm picking, I'm clicking. I'm sure if I happen to get like 3 more, I'll be good to go.
Okay.
Though the more you get into more ideas, at least, yeah, you learn some.